Okay, here is example C. And as I start looking at example C, I notice that on the top, there is a pattern of something squared plus something minus 7. The only problem is that these two trig ratios don't match right now. So that's no good. We'll have to deal with that in a second. On the bottom, I recognize another pattern, 27 sine cubed minus 125. Well, that looks to me like a difference of cubes. We talked about that yesterday. So the first thing I'm going to do is make sure that on the top, in the numerator, I have the same trig ratio. I want these to match. And I can't think of, well, I can, but I'd rather not change the sine x. I can think of a better identity that I can use with cos squared x, and that is cos squared x is equal to 1 minus sine squared x. We know that cos squared plus sine squared is equal to 1, so if I rearrange that identity, I get this. And I'm going to use that right now to help me simplify this a little bit better. So here we have negative 3 times 1 minus sine squared x plus sine x, take away 7, all divided by. Since I know that this is a difference of cubes, I'm going to factor it that way right now. So I know that when it's a difference, the first term will be a, which is the cube root of this term, minus b, which is the cube root of that term. And that is 3 sine x minus 5. In order to get the rest of this factored version of a difference of cubes, we square the first term, and the first term squared is 9 sine squared x. Then we multiply the first and the second term together. That's negative 15 sine x times negative 1 plus 15 sine x. And finally, we square the last term. Negative 5 squared is plus 25. So that's me factoring the bottom as a difference of cubes. Let's keep going with the top now. Negative 3 expanded in is negative 3 plus 3 sine squared x plus sine x minus 7. And I'm going to be pretty lazy right now, unfortunately. I know you'll be laughing at this. I'm going to put quotation marks because it's the same thing. I'm just not going to write the whole thing out to save time. Next, let's combine all our like terms together. Well, I see I've got two constants here. Negative 3 and negative 7 combines to give me negative 10. So all together we have 3 sine squared x plus sine x minus 10 all over, quote, quote, same. This, although I'm running out of room here, I'm going to have to move up here. This is not technically a nice way to do math, obviously, because on your test I said formatting issues. What's the formatting issue? And yet here I am doing this exact same thing. Anyways, don't do as I do, do as I say. Okay, how do I factor 3 sine squared plus sine x minus 10? Well, I can use variable replacement here and think of it as 3a squared plus a minus 10. And if I do that, then I have 3a squared plus a minus 10, which factors into 3a squared plus 6a minus 5a minus 10, which is 3a times a plus 2 minus 5 times a plus 2, which is a plus 2 times 3a minus 5. So now I know what this factors into. I can use a as a simple version of sine x, but I've got to remember to replace it back again, right? So this is now sine x plus 2 times 3 sine x minus 5, all divided by, and this time I won't cheat, 3 sine x minus 5 times 9 sine squared x plus 15 sine x plus 25. I'm looking at this factored version now and thinking to myself, is there anything factor-wise on the top and bottom that I can reduce that would give me the exact same answer? And yes, there is. 3 sine x minus 5 appears on the top and bottom. We can reduce those to 1 over 1 and get our final answer here of sine x plus 2 all divided by 9 sine squared x plus 15 sine x plus 25. And we're done.